Well, good morning, everybody. I do want to make mention on the last quiz, because the last quiz obviously involved Green's theorem. Many of you questioned yourself on the second problem because you said, wait a minute, I have an integral of 0, but we know exactly what that means. We know that if the nx minus my is 0, we know that means we have a conservative force. And the most important part about a conservative force is it only matters where you begin and where you end. If you have a conservative force, then your integral is path independent. And that means that when I have a closed loop of my mdx and ndy, this is going to be 0 because it's path independent for a conservative force. So when you guys did this and you got 0, you're saying, wait a minute, how could that be? Well, no, that was the whole point of the problem. Do you recognize when you can just stop and say the answer is 0? Now, in the first problem, no, it's not 0. So I'm going to use Green's theorem. I'm going to integrate over the double integral. And most people did a pretty good job. We had some plus or minus sign errors, but for the most part, people did good work. Now, today we're going to do an extension. And what we're really going to do is try to create a situation where we can do a version of Green's theorem, but in 3 dimensions. And this is very, very powerful. Okay, so let's start with what we already know. I got a good black pen here. So we already know, hold on a second. Oh, left it there. Hold on. Okay. So if I have a simple situation here, I have a simple line integral from point A to point B. Here's my curve. And I want to do the integration, okay, mdx plus ndy over this curve. Now, this means, right now, this means that I know that my force vector is mn. And again, that's m of xy, n of xy. It's 2-dimensional. Life is good. There's not really a question. This is equal to work. But we showed recently, this is also equal to f dot t ds. And that's a small s, you remember. And that's also equal to f dot dr, where technically that's dr dt integrated with respect to t. These are the 3 versions of work that we've covered so far. These all mean and they all say exactly the same thing. So let me throw a what if at you. What if, okay, this picture goes with these 3 integrals. What if instead of this, I have a closed loop? Well, then that means that this is a closed loop. That means this is a closed loop. And in each case, we then know that this will equal the double integral over the region in the xy plane of the partial of n with respect to x minus the partial of m with respect to y integrated over the area. That's Green's theorem. Okay, that was major proof last week. So it's no longer this picture. Now, basically, it's, this picture. I now have a closed loop. So this is what we want to dwell on, okay? Something of this form, but now what I want to do is start moving into 3 dimensions because this is where the power is. You see, Green's theorem only applies in 2 dimensions. It applies on the xy plane, but I'd like to know if I'm moving in 3 dimensions, is there an analogy? So let's create the analogy and then see where this goes. So what if, keep sending down my black pens. So what if I have a picture like this? I am in 3D, but my path, my closed path, is purely 2-dimensional. This is a 2-dimensional path. I'll do this if it helps. This path lives completely on the xy plane. Okay, even though I'm in 3D, my path is strictly 2-dimensional, and my force, m of xyz, n of xyz, 0. My force has no vertical component. So my force, even though I'm a completely 3-dimensional problem, that'd be kind of like I'm standing in a 3-dimensional world, but my floor in a three-dimensional world, my floor still looks like a two dimensions. My floor looks like my XY plane, even though I'm in 3D. My floor has 0 Z component. So I'm 3D, but my path is completely on the XY plane and my force is completely on the XY plane. Does this change? Well, no, but what I can now do is I can use this fact, okay, to then sort of segue into 3D. Now, my normal vector would be right about here. There's my n. It's pointing straight up in the Z direction. In fact, it would be 0, 0, 1, quite obviously. So I'll even say that. My normal vector is 0, 0, 1. It's a unit vector in the Z direction. Interestingly enough, what is the curl of F? Well, if I put my little partial with respect to X, partial with respect to Y, I'm lazy, I do it like this. 0 minus 0, 0 minus 0. Oh, the 0 vector? No. Nx minus my. Ah, that's the part in Green's theorem, isn't it? Now I want you to notice something else. If I do the curl of F and I dot it with n, this dotted with this, I'm going to get nx minus my. Huh. And remember, this is living completely in the xy plane. So now, if I go back to my previous, I already know what this is, right? We just did this. This is work around a loop on the xy plane in 2 dimensions. Well, technically, that's kind of what I'm asking here. Even though it's a 3-dimensional problem, it's a 2-dimensional picture. So based on this information, this is the equivalent of saying the following. Because this equals okay, this is Green's theorem. Okay, there's no question, this is the Green's theorem result. But I'm going to represent it in this form because I now have a 3-dimensional problem. I can't do curl in 2 dimensions. There's no such thing. There's no analogy. But I can do curl in 3D. And that's what I got. And then when I dotted it with the vertical normal, I got the Green's theorem. So with this picture, with my loop being in 2 dimensions here, and my normal pointing straight up, Green's theorem and these are absolutely equal. Okay. So now we're ready for one more little tweak, because I've now made Green's theorem 3-dimensional, but this is kind of a huge assumption. I'm in 3D, but all of my motion is on the floor and all of my forces live on the floor. That doesn't feel very 3D yet. So now here's what we're going to do. Now that we have this, I'm going to change the path. And this is actually quite brilliant. This part here. I'm now going to change the path. This is now angled. Think of this as angled, right? I am now cutting across 3 dimensions. This path is not on the XY plane anymore. It's 3D. In fact, we'll say that the normal vector maybe points that way. The normal vector is pointing out. My path is not. My path is still on a plane, but it's in 3D. Okay, so now what changes? Well, first of all, my F now is M and P. Like before, all 3 functions are functions of X, Y, and Z. Okay, that part stays exactly the same. My path is M, N, and P, but if I make that my path, then this is not exactly the same. Now I can say, I still want to do this, okay? But this is not the region in the XY plane. Think surface area, think surface integral. On surface area and surface integral, remember, I took something I took my surface and I projected it onto the floor. This is supposed to represent my surface at an angle. I projected it onto the floor. The projection onto the floor is Rxy. But what is it I was projecting onto the floor? The surface. This is big S. Oh, now we know exactly how to make that look like this. But now that my path is three-dimensional, I need to project that onto the ground. That's the ds equaling, square root of stuff dA that we're very familiar with. This is if my path lived entirely on the XY plane. That's why it's already the region in the XY plane. Now my path is in 3D, so I'm integrating over the surface, so I will eventually project it. So this in 2 dimensions we can go directly to Green's theorem. In 3 dimensions on the XY plane, it looks exactly like Green's theorem written in this form. Now when I tilt it, the difference between these are my path was already in the XY plane. Now I've got to project it onto the XY plane. So we know exactly what to do with this. We know exactly that this will become the double integral over the region in the XY plane of the curl of f dot n square root of stuff dA. I'll just leave stuff, fx squared plus fy squared. We already know what to do there. But this is the form now we want. And this, basically 3-dimensional version, if you will, of Green's theorem is called Stokes theorem. And in most cases, it's not that bad. You say, but boy, flux was really complicated. F dot n could be really, really huge. You're right. But curl of f tends to be a little smaller than f because curl of f involves taking partial derivatives. And whenever you take derivatives, unless you've got a wicked chain rule or product rule or something, when you're taking derivatives in 3D, you guys know that your derivatives tend to get smaller, not bigger, right? Rarely do you see your derivatives in 3D getting more, than the original function. So I want to do a couple examples of this now. So first example, let me do this. Actually wrote down the problem. All right, so we're going to do, so the problem usually starts like this. And by the way, this is where you do want to pay attention to detail. Capital S means I'm integrating over the surface. Small s means I'm integrating over the arc length. It's very different, not even similar. Okay, not only different formulas, but just different way of looking at the problem. Okay, F is going to be, let's see. Okay, and then my surface is, let's see. Sorry, I can't remember. My eyes are not working. Let's see. And in the first octet, okay? So graphically, what that would look like. I mean, we're quite familiar with this. I hope we are at this point. So 2 0 0 0 0 3 0 0 or 0 3 0 0 0 6. So I am that portion of the plane in the first octave. This does not go on forever. I'm cut off by the XY, XZ, and YZ planes. So my normal vector clearly is going to point in a this way direction. And the reason that's important, remember when we're creating our gradient, we're creating our G function, do we go f of xy minus z, or do we go z minus f of xy? Anybody want to help me on this one? Are we going to go f of xy minus z or z minus f of xy? You only got 2 choices, so it's 50-50. Z minus or f minus?
Z minus?
Minus
Why Z minus?
Because it's
on the
positive.
first octave.
Well, because then the partial with respect to Z will be +1 versus -1. That's actually the simple reason. If it's F minus Z, then that partial will be -1. And will that make a difference in the end? Yeah, it'll affect the sign of my final answer. People say, oh, is that a big deal? Think of it in terms of money, profit versus loss. Yeah, that might make a difference. So I'm clearly going to let G of X, Y, Z, and you just said how we wanted to do it. Well, I guess I can kind of leave it in this form, can't I? So it'll be 3x plus 2y plus z minus 6. All right, that's going to be my G of X, Y, Z. Then my gradient of G will be 3, 2, 1. The length of my gradient of G will be 3 squared plus 2 squared plus 1 squared under the root, which would be what? Root 14. Therefore, my normal vector is 1 over root 14, 3, 2, 1. Now, there's nothing wrong with distributing, but we know we're going to get some canceling a little later. Now I need to do my surface area parameter. So that means I need to explicitly define an f of xy. And by the way, the other reason I need to define an f of xy for 2 reasons. One is so I can do the ds as root dA, but also in case I have to replace this z, because remember, this is a double integral and I have 3 variables. That could run, that could give me trouble later. I don't know yet. If there's a z in my final answer, it has to be substituted out. So in this case here, z, which will equal f of xy, will equal, throw everything on the other side, 6 minus 3x minus 2y. So again, I'm doing this for twofold. One, for the ds to give me my surface area parameter. And secondly, in case I actually have to substitute to get rid of a z. I'm not going to do it yet because I have to take a curl vector at some point. I'd rather take a curl vector with the z and then sub later than sub now and then take the curl vector, because that's more algebra. Okay, so now I've got my n. Let's do our ds. So fx is, where are we? -3. Fy is -2. So ds is 9 plus 4 plus 1 dA, or root 14 dA. And that's a good thing because that root 14 will end up canceling with that root 14. But I still now need to find the curl of f. Right? I'm not out of the woods yet. So the curl of f. So the easiest way to do that, right? My x, my y, my z. So the curl would be this minus this. Okay, so 8y minus 0. 6z minus 0. 36x minus 0. Okay, so hopefully we all have the same thing at this point. Now, at this point in the game, I'm going to do this dotted with this. Okay, we can do this all at once, and I'll write it here. Curl of f dotted with n ds. All right, so then that way I can cancel the root 14s. So I'm doing curl dotted with this. So that would be 24y plus 12z plus 36x dA. Okay, this is where we are right now. Okay, so hopefully everybody recognizes that. Now, I think I could probably factor out what, a 12, and then I'd have 3x plus 2y plus z dA. Why did I write it like that? Well, I just put them in alphabetical order. Anybody notice anything really cool about right now? I'm bounded by this plane. This is my integrand. Anybody notice anything? This quantity right here equals what? What does this quantity equal?
6.
6. I don't know about you, but that makes me very happy because now my integrand just reduced all the way down to 12 times 6. Oh my goosh. Now we haven't done our integral yet. We did all of the work. But like I said before, the curl of f is generally much friendlier than f itself. And when I did curl dot n, by the way, this isn't always going to happen. It just worked out perfectly because of my judicious choice of coefficients and things of that nature. So now I can go all the way back to here. And let's see, the question is, where am I going to write it? I'll put it right here. I don't need this anymore. Okay, so now we've got, this is equal to the integral over the region in the xy plane of 72 dA. Now the question is, what is the region in the xy plane looking like? Oh, so what I want now, I just simply want that triangle. I don't need the tetrahedron anymore. I don't need the triangular face anymore. I just need that little triangle, because now we're looking at this in the xy plane. So in the xy plane, all right, in the xy plane, we have 3x plus 2y is 6 because z is 0 in the xy plane. So I'm going to have 2, 0, and I'm going to have 3, 0, and it's going to something like this. All right, except that it's straight. And we're that. So if I solve for y, I'll have y equals 3 minus 3 halves x. If I solve for x, I'm going to get a fraction for y. So there's really no advantage either way. You know me, I like to avoid the fractions if I can, but in this case, I can't. So let's just go ahead and do vertical rectangles. So if I do vertical rectangles, so x is going from 0 to 2. Y is going from y equals 0 to y equals 3 minus 3 halves x of 72 dA. Okay, that's very nice. Oh, I'm sorry. Now it's 72 dy dx. Sorry, we're going in that order. So this would be so replace y with 3 minus 3 halves x. So 72 times 3 minus 72 times 3 halves. What would that be? 324x. And then dx. I believe that's what we have so far. Hopefully, let's make quick sure here. Yeah, okay. So at this point, what do we got? We've got 216x. Something doesn't feel right. Hold on. Oh. Sorry, what did I do? I did 3 halves times 216. My bad. I'm looking at this but something doesn't feel right. 72 times 3 halves. I did 216 times 3 halves. 72 times 3 halves would be 108. Sorry about that. Now, this will be 54x squared from 0 to 2. So my final calculation, I'm going to have 432 minus 54 times 16. That would be, I'm sorry, 54 times 4, not 16. And I think that gives us 216. Okay, now what does this mean? Well, this is the value of our integral. We're not going with units right now. what did we find? What physical thing did we find? In other words, did we find power, force, energy? Anybody?
Work.
We found work. Yeah, lest we forget, we found work. But we found work done on that, yeah, I erased it. My three-dimensional, that triangular face of the tetrahedron, that's what we were moving around. That was my path. Okay, we found work around that path. Now, remember I said at the beginning of the course, if you could sum up this course with one problem, it would be my wheelbarrow that's full of stuff. My wheelbarrow has holes in it, and there's a torrential downpour, and water's filling it up and water's spilling out, and stuff's flying out of my wheelbarrow. The force is constantly changing. I'm starting at one point and I'm ending somewhere else. How much work did I get done? Or I started and I came back to the start. How much work did I get done? And before you say zero, you would have to have a conservative force, which usually you don't. If you did have a conservative force, how would I know if I had a conservative force in this problem? Can anybody tell me, how would I know if I had a conservative force in this problem?
The curl would be equal to 0.
Which part would be 0? This guy. I put right there. Because what was this? That was the curl of f dotted with stuff. My curl vector would have been the 0 vector. So therefore, the curl dotted with anything would have been the number 0. That's how you would have known. Okay, so is it possible? Of course it's possible. Is it common? No, it's special. Okay. Hold on, I had another. Hang on a second. I wrote down another problem. I got to figure out where I wrote it. Give me 1 second. Oh, here we go. I wrote more than one example. I tend not to wing these ones because they're too long and complicated. We'll do one more example and then we'll start talking about the exam. Most folks won't have a lot of difficulty using Stokes' theorem because, like I said before, you tend to have slightly simpler integrations. In other words, the flux problem and the Stokes theorem problem are easily confused. Can anybody tell me why flux and Stokes' theorem can easily be confused? That's not a trick question, but you got to think about it. What is flux? Okay, what is flux again? Okay, what does Stokes' theorem say? I'll just put Stokes. Can you see why these are easily confused? F dot n, curl F dot n. Same ds, same region, same everything else. This is F, this is curl F. My experience is the Stokes is generally less difficult, less work, because the curl of F tends to be a little smaller, which means your integrand in this case tends to not be as gnarly as this one. That doesn't mean you can't do this one. That just means there might be more involved. So that's why they're often confused, is because they look really similar, but they're actually quite different. All right, let's do another one. Let's find okay, so all you need to know is the force and the surface. So my force is 3, 4, and my surface is the paraboloid cut off by the XY plane. You know me and my love for paraboloids because they're so much fun. You know, that. So the paraboloid that is cut off by the XY plane. So my downwards pointing gumdrop, my bullet. So my surface is this. So that tells me something about my normal vector. So once again, my normal is going to be pointed above the XY plane, which means that affects how I set up my gradient vector. So that's clearly my f of xy. Okay, so hopefully we all do the same thing here. So now when I'm setting up my g, I'm creating G, so that's why I say let G be. Anybody want to tell me what does my G have to be?
Z minus fx.
Okay, so if I'm writing it out, what's probably the cleanest way to write it? So what you're saying is throw everything on the other side. I got it? That would be the easiest way to write it. Z minus this quantity would be this. Okay, that's not bad. Now my gradient, 2x, 2y, 1. The length of my gradient, 4x squared plus 4y squared plus 1 under the root. Therefore, my normal vector is 1 over the root. Again, times this. All right. There's kind of an order of things. You don't have to go exactly in the right order, but you don't want to do things prematurely. I don't want to do a dot product before I finish the other stuff. So the next thing I want to do is I want to find ds. I usually like doing that next. So now I go back to f of xy is this. And again, that may matter because I may need to swap out this z for this stuff if z shows up after I take my curl. But it's only after I take my curl that I have to concern myself. Or really even technically, after I do my dot product with n, if there's still a z in that expression, which by the way, most of the time there would be. There wasn't in the last example, but that doesn't mean that you won't. It means that the z can get canceled, it can go away, but if there's still a z after you do your dot product, you're about to write a double integral with x, y, and z. That's why you would swap this out at that point. So in our case here, if f of xy is this quantity, then fx is negative 2x, fy is negative 2y. My ds is then 4x squared plus 4y squared plus 1 dA. Okay, I'm looking good so far. Now the next thing, I need my curl vector. Now, some of you can do this in your head. Some of you can actually do the curl without thinking. I can, but I don't need to because this is too easy what I'm doing here. Because I want to make sure I subtract in the right order. You know, that sometimes is a problem. 2 minus 0. 3 minus 0. 4 minus 0. Okay, that looked pretty friendly. Okay. And this is the last real piece of the puzzle before we're ready to write our integral. The curl of f dotted with n ds. So when I dot this with n, I'm going to get 4x plus 6y plus 4. I'm also going to have, where is it? 1 over the root times the root dA. Isn't that nice? And there is no z in that statement. By the way, in the last example, there was a z at this point, but we were able to swap it out for a constant as we saw. Okay, so this is going to be my integrand. I kind of like that. That's very, very friendly. So I'll put it up here. I can fit this up here. So right now we have, this is the integral over the region in the xy plane of 4x plus 6y plus 4 dA. Now I'm not quite done because there's something special about this particular region. Anybody want to tell me about this particular region? This is a nice happy rectangular integrand.
Do you use polar coordinates?
Yeah, because what's my region?
A circle?
A circle. Oh, in fact, do we know exactly what circle it is? We have enough information. Let me. I'm always hesitant to erase, but I think
Circle with radius 3.
Yeah, and how do you know it's radius 3?
You bring the x squared minus y squared, the minus x squared minus y squared over to the other side.
Well, we can just do this. Z equals this, z equals 0. So I set this equal to 0. Does everyone see that? I want the intersection of where that curve is equal 0. So this is x squared plus y squared equals 9. So as Ian suggests, this is a circle of radius 3 centered at the origin. I think we're very happy with that. That's about as friendly a region as we're going to get. So circle of radius 3 centered at the origin. So I now have 0 to 2 pi, 0 to 3, but now what? I got to convert these to polar, so that would be 4r cos theta plus 6r sine theta plus 4, that's supposed to be a 4, r dr d theta. Don't forget that r. That will make a huge difference if I mess that up. So I will now distribute. This is not going to be a challenging problem, but there are a few steps because I don't have any constants right now. So I'm going to integrate with respect to r first. Okay, so we'll have 4/3 r cubed cos theta plus 2r cubed sine theta plus 2r squared from 0 to 3 d theta. I think this will not be bad. I don't even think we're going to have a fraction here. So 4/3 times 27, that'd just be 36 cos theta. 2 times 27, so plus 54 sine theta. 9 times 2 plus 18. Okay, and finally, integrating this, that's going to give me 36 sine theta minus 54 cos theta plus 18 theta from 0 to 2 pi. Here's why we love 0 to 2 pi. What are these trig functions going to be when I evaluate them from 0 to 2 pi?
0.
0, because the cosine of 2 pi equals the cosine of 0. They'll cancel, and the sine of 2 pi equals the sine of 0 equals 0. So all that cancels. So what's left? This bad boy right here. Much rejoicing, right? Confetti in the streets. Everyone goes crazy wild. That's it. Now, is it a long process? Yeah. Is it a difficult process? Probably not. Yeah, it would be easy to create a problem that was just nasty and scary. But if you had the nasty, scary problem, it would probably be set up the integral to find the answer. And you see, the most important part of this problem is not this. The most important part of this problem is this. Okay, because depending on my integrand, it's going to depend whether I can actually proceed, but we can do this. Now, we're done with this. I want to talk about the exam. I will reserve a lot of time to review. So just a reminder, because it feels like it's been about 1,000,000 years since our last exam. The exam is Thursday morning, as you know. And like before, I will email you the exams about 10 minutes early, so you can either print the exam, which is my preferred, or you can just work on your screen, which means you can't look away for 2 hours. And that's, that's taxing on the eyes. You may create a 3x5 card of theorems, formulas, definitions, and you probably have a few on this one that you didn't have on the last one. Things like surface area, perhaps Green's theorem. There's a couple of them in there that you might say, yeah. I mean, let's face it, cylindrical coordinates versus spherical coordinates. What is the actual substitution? Big yikes. You may use, again, scientific calculator. Integration should not be an issue. The integrations themselves have all been low level. I mean, all you've done with your integrations for the most part are polynomials, sines and cosines, maybe an E. It's really not complicated integrations. It's really about the setup. So if you have done the practice test and you were able to get the problems right, if you've been doing the quizzes and you got the problems right, you're good to go. The exam is not very long and there's not a lot of questions because the questions themselves are pretty beefy. Okay, most of the questions, I call them big ticket items. I mean, they're not small details. So on the test, I believe I gave you 10 questions and you have to do 8 of them. That means you got about 15 minutes per question, and really there is no question There's not even a chance any question should take somebody 15. You really shouldn't take anybody 10. If you know how to do the problem, you're going to finish most of them much faster than that. But you have time. And so, like before, I'm giving you more questions than you have to do. So you want to make sure you have 8 valid attempts and there's an extra credit. So the order of things is the same. Get 8 problems, answer them to the best of your ability. Now check your work. Look for the typos, look for the small errors or the big errors, fix them if they're there. If there's time on the clock, do the extra credit. And most of you, there will still be plenty of time on the clock. Now go back and do an extra problem as insurance, because it is quite possible that in those first 8, there's one that you just totally messed up and didn't realize it, and you won't realize it till later. So I always suggest doing one extra problem than you have to as insurance. Should you do all 10? No, because you know the 10th one's not going to count. I mean, you put it off for a reason. The chances are there's no way the 10th problem is going to somehow supersede 2 previous problems. That's probably not going to happen. So do you have to have 8 great answers? No, you have to have 4 or 5 great answers. Then you can have a couple that aren't as great, maybe even one that's not very good at all. And that's probably a B right there. So this is an exam that I think it's safe to say, from a calculus standpoint, it's the last exam that you're having in a calculus class. So most people say, yeah, this is probably the hardest calculus exam I've ever taken. And having said that, the results on this exam tend to be the highest most people have had. The last exam tends to be very, very strong, because if you're sitting in this class, this is stuff you've probably gotten really good at. And so that's really not going to be the issue. So here's how it works. You're going to take the test. Of course, you're going to email it back to me at this address. I actually have people that tell me they're still trying to send stuff to Outlook. I have not received an Outlook email from a student in 10 weeks now. That's how long ago we switched over to this one. So if you're still trying to send stuff to Outlook, why? I will never know if you sent something to Outlook, but I have almost daily stuff. People tell me, oh, I sent it to the Outlook email. Really, after 10 weeks? that worries me that somebody's memory is that bad. No, I can't receive your emails through Outlook. I'm not even going to look for your emails through Outlook. I haven't logged on for student email in, well, 10 weeks. I get everything through this email address. So we'll continue that. You're going to send it back. Yours is the first of all the exams that I'm giving. I'm giving the rest on Monday and Tuesday, which means I should be done with these exams pretty darn fast. Probably Friday at the latest. And what that means is, at that point in the semester, you just turned in your 23rd quiz today. That means there's only 3 quizzes left in the entire semester. So, 99% of your course grade is basically more or less decided if you don't want to take the final. So if you haven't done this before, you really need to do this. Go to Canvas, go to the grades, hover the cursor over your total. And if you've reached the threshold for an A, B, or a C after the exam, that means you're guaranteed that grade, right? And that's, most of you know exactly where you stand and exactly what you need. Then also, after the exams are done and grades are posted, if you haven't got the A and you want the A, then you go through and say, okay, if I go through and drop my lowest scores, now what do I need on the final exam? There are 3 quizzes remaining, okay? It would be unwise not to turn them in, because turning them in means that you have the potential to raise your grade from wherever you are now. I mean, that's close to 100 points. In fact, if I think I threw a bonus on one of them, so you're probably talking 100 points. Not turning them in is sacrificing a potential grade raise, if you will. So do all those remaining quizzes. Approach everything right now as if you have to take the final, and be pleasantly surprised if you don't. Because if you do it the other way around, then you're going to wait till the last minute and say, oh no, I have to take the final and I haven't started preparing. All right, we will take a short break, and when we come back, it'll all be about the exam and the questions. Oops, sorry, go to the gallery view first. There we go. That, by the way, that is not a good reason to shack up with your girlfriend. I mean, come on. Yeah,
Have you ever done a long distance relationship before?
yeah,
For 2 years?
for two, not for 2 years, but yeah,
Well, I'm doing what I can.
you're doing well.
Don't have a lot of options.
All righty.
Which quizzes exactly are on the exam?
Hold on, let's see.
I think it's 16 to 23 is what I calculated.
Sounds right-ish. Here we go. Now, the last exam, all you gotta do is look at the quiz before. Yeah, the last exam went through 15, so this would be 16 through what you turned in today. So 8 quizzes, 16 through 23. Okay, and as always, it's a good idea to retake all the quizzes if you haven't, just to make sure, okay, I understand these. The main thing is to be able to separate problems. You know, surface area versus a surface integral, you know, something like that. Heck, something as simple as divergence versus curl. I mean, you know, spherical versus cylindrical. You know, so you just want to make sure a moment versus a mass. Yeah, so when you're asking what formula should I write down, well, I've just given you a few, right? The mass formula, the moment formula, surface area. Although I think at this point, surface areas, you guys, that's probably one you have. Now, Ian, you're going to send me
Already-
formulas.
Already
sometime?
just sent it.
Oh, you are? Oh, okay, beautiful, beautiful.
And then
Has that been an issue at all? That part of it?
no, so I don't even think, I think you received it because you responded to me in the email that I sent on time and said, not like you to not turn in your work. So I think you saw it, but you must have seen my other email as well.
I probably saw well, I actually had more than one person, by the way, this round say, oh, shoot. Basically, I forgot to turn it in but I'm going to go ahead and give it to you so you can give me feedback. I get people will do things like that.
Yeah, I just opened it up on my phone and the email was still on my phone. And I'm like, no. And it was after class. I was like, no. And so I just added in the feedback part, sent it. And then like an hour later, I checked and I had sent you 2 versions of the quiz, one before the
Yeah,
time.
as long as I have it before, because I will
Yeah.
have, every now and then I have somebody, this is a great one. I had somebody, and I don't remember which class it wasn't this class, turns it in, and it was about an hour after I'd posted the key. And they said, I just realized I hadn't turned it in. I promise I haven't looked at the key. I just thought that was pretty funny. Well, they actually got a 0 on the quiz. They weren't even ballpark. So I'm thinking, well, no, they didn't look at the key because 90% of the class got 100%. I don't even know what they were doing, but it is a person who doesn't attend lectures, is not doing particularly well, failed both exams, doesn't have a textbook, admitted they sometimes watch the lectures after the fact, and it's their 4th time taking Calc 1, which means it's their last time in California taking Calc. I mean, it's like, you set yourself up for failure, but I loved it though. I promise I haven't looked at the key. Well, looking at their quiz, yeah, I believe them. I mean, it was kind of silly, you know, but yeah, I'll just take a peek at it later when I get a chance. I wouldn't worry about it too much. You're in pretty good
Sweet.
shape.
Yeah, I'm always not that worried as long as I have the proof. The timestamp is really
Yeah,
saving.
and you know what? Again, in this weird world we're living in, I'm surprised how often this is happening. But this is more of a cell phone thing. Cell phones are notorious for this. Sometimes it might be the size of the thing you're sending. I don't know what it is, but I'll have people do this. Here's a perfect example. I will probably get a quiz turned in sometime late afternoon to early evening today from your class, where the person probably turned it in on time, but it will arrive 4, 5, 6 o'clock p.m. And I'll look at it and I'll open up the quiz and it might say 9 a.m. But I will receive it this evening. This happens every single class, every single quiz to somebody, but it's never the same person. That's the odd thing. Yeah, so don't worry about it. I believe you. It'll show up and you'll be vindicated. Just when I posted the grades, I literally hadn't come in yet, not even the late version.
Sweet. Also, I don't see that the quiz 23 has been the key has been posted.
Oh, you know what? It's been posted. I may not have moved it. It may be at the bottom when you look. Oh, no, you're right. Nope, thank you, Ian. I did have it. I just did not click send. Okay, there we go.
I see it now.
Yeah, I had it. I always have it in the same way. I have it, so all I got to do is click, and it was still in the I have to click mode. No, that one was actually pretty good. The only errors. What's interesting is the majority of the class so far that I've looked at decided to use rectangular coordinates rather than polar. Which, by the way, this is one of these rare times where you could do it either way, and it's probably the same difficulty. But if you use rectangular, it made it a little trickier on the order because it was the left side of a circle. A lot of people have their boundaries backwards, which changes the sign of the answer. But if you did polar, you probably didn't, you probably had things in the right order. It's
I had it negative, and for some reason I thought it wasn't supposed to be negative, so I just basically took all the negatives and put it into positives. I had negative 20. No, I had negative 20. Sorry, 2048.
Jose, you've told me that before. It's like you don't trust your brain said this is what it's supposed to be, and you're right. And you're right most of the time, but you tell me this all the time. You go, I didn't trust that answer, so I see you're not.
Well, for some reason, I saw it and I was like, something just doesn't look good. I mean, it can't be negative. And then I was like, wait, it can't be negative. And then I was like, it was too late, so I just turned it in.
Tell me what can't be negative. There's a few things that can't be. Mass, volume, measurements, surface area, arc length, something where you're physically measuring a static object. Okay, can work be negative?
No.
Yeah.
Well, it can.
Oh,
Yeah.
absolutely. Remember, if the force is in an opposite direction from the distance, the way I like to say is I want to push the car uphill. So I say, okay, Ian, go ahead, take off the brake, and what's going to happen? It's going to start rolling on me, and then you're going to hit the brake. We got negative work done because we now have to do positive work to get it back to the starting position. No, negative work makes perfect sense. Because negative, remember, if the force and the way you want to measure it are in the same direction, it's easy. But what if the direction's at 90 degrees to the force? Well, then we know it's zero. Oh, so what if the angle's obtuse?
Wait, so if I did it in rectangular instead of doing it in polar, it should be positive or negative?
Oh, no, it's the same answer. I'm just saying if the people that did it in rectangular, a lot of them had their limits backwards. And the funny thing is people drew a correct picture, but then, and now remember when you're drawing and you're integrating in this case with respect to Y, or you're doing a delta Y cut. So you're going to go left to right. You're not going to go right to left. That would be backwards. Kind of like when you're doing vertical, you go bottom to top. You don't go top to bottom. That would be backwards. So your left limit would be the outer edge of the circle. Your right limit would be zero. And so what I noticed is the only wrong answers came from the rectangulars when it came to the sign errors.
I mean, I did rectangular. For some reason, I did a rectangular, and I got a negative. I actually got a negative, and then I went back and I started changing signs because I was like, it doesn't make sense because of the way that my limits were. I knew it had to be from -4 to 4, but I had a feeling that it was from 4 to -4 since it had to be the other way around. So initially I put from 4 to -4, but now I thought about it and I just did it the other way around. I put from -4 to 4.
So I can find this. I have it somewhere in the room here.
What did you put the inner integral at? The bounds for the inner.
The inner was from 0 to -√16 minus y squared.
Those were supposed to be swapped.
Mm-hmm.
Oh,
That's what I'm saying.
yeah, I set it up in rectangular and I ended up doing it correctly, but my answer got swapped to positive at the very last second. I just 3,000 minus 5,000 doesn't equal a positive number, but I said it did. So
yeah, you guys killed me. You guys great on the calculus, terrible on the arithmetic.
I know.
I mean, I had -5,000 minus plus 3,000. I was like, okay, well that makes sense. It's negative.
Did you get 0 for the second problem?
Yes.
Yeah, we did.
That was
of all 4 classes I teach, I got more questions on that problem than anyone. It can't be 0.
Yeah.
What am I doing wrong? It's like, what do you mean? This has been kind of a major theme of the course. Conservative force, you're supposed to get 0. That by the way, did you notice anything about the point values? The second one was only worth 10 points. Is that kind of a hint that maybe it wasn't very long?
when we were doing the conservative functions, and I was like thinking this is too easy, like it shouldn't have been, like it was 2 quizzes ago. But then I looked and I saw that there were 5 points each and the previous one was 20 points. I was like, okay, maybe it's not too easy, and then I just did it correctly.
Yeah, we are good at talking ourselves out of stuff. Now, with an exam in 2 days, if you are ready, please do not start stressing and thinking that you've got it wrong. These problems, for the most part, there's no abstraction whatsoever. And a lot of times you just take the problem and it self-navigates. If it's an integration, you just integrate. But a lot of what we're doing with the line integrals does require correct setup. But as you've noticed, when you're parameterizing the line integral and you're integrating, t to the third power from 0 to 2. I mean, that's what you're ending up with at the end of the problems. And you're going, man, these are really easy. But the whole problem was to get it to that point. The problem, it's not about the answer. It's about getting it to the part where you can integrate. The original statement on problem 1 is a very scary looking problem. I have a closed loop with a big, nasty bunch of polynomial-ish things. When you apply Green's theorem, now your integrand's 15xy squared. Oh my gosh, that's huge. Now I got to get the correct limits of integration. So if I can set up my integral correctly, the actual integration is low level compared to everything else we've done. Now, obviously you want to get that right because you know how to do that. You've done 1,000 of those. And that's why I say, if you're doing a measurement of a static object like mass or height or volume or weight, yes, that has to be a positive number. But whenever you're just simply evaluating an integral, taking a derivative and evaluating it, anything's fair game. So that's where you got to step back and say, wait a minute. Now, are there times when you actually do have to think about positive and negative? And it could be the one. Yeah, I'll give you an example. Moment. You're finding a center of mass. Mass cannot be negative, but moment can. Because if my center of mass is not in the first quadrant, there has to be a negative moment, doesn't there? In fact, if my center of mass is in the third quadrant, I'd say something's two-dimensional. If my center of mass is in the third quadrant, then both moments have to be negative because the x bar is the moment divided by the mass, and the mass has to be strictly positive. Now, can a moment be 0?
Yes.
Yes, that means I'm on an axis. And we did some of these
moments on the exam.
Yeah, that's the only really application in triple integrals. Is, do you remember the problem we did with the cranberry sauce?
Mm-hmm.
We found the center of mass, and one of the things we noticed was x bar and y bar were both 0. So the center of mass was on the z-axis, which makes perfect sense because center of mass shouldn't change horizontally; it should only change vertically. If I'm just thinking about something settling in a can. Does that make sense? So there would be a perfect example of people say, well, I can't get 0. Well, I can't get 0 mass. No, that'd be bad because that's my denominator. And yes, you can get a negative moment if x bar, y bar, or z bar is negative, then the moment that goes with it has to be negative because you never get a negative coordinate. But a negative coordinate's okay. So in the center of mass problems, mass is the only thing that has to be strictly positive. And again, I remind you, work can be negative. Work, in fact, in the conservative case, work is 0. So I did all of this work, but I ended up where I started and it was conservative. And that's why. So the calculus, you guys are probably fine. I need you not to talk yourself out of answers, though. And it sounds like both of you have done that recently, if not today.
Well, yeah. I just made the simple algebra mistake. I'm usually pretty good at not talking myself out of the answers because I've seen some of the answers that are just like come out nasty and it's not really like pi over 3 times 27 times square root of 2 minus like 40, like something like that. And I'm like, that doesn't seem very clean, but so it's proven to be right sometimes. So
it never has to be clean. It just in a math sense, we tend to make it clean. And it's probably not in your best long-term interest, but in math we tend to make it clean so you don't get caught up on the calculations. You get caught up on the math. You make the calculations friendlier because then you're sitting in physics, and if you get a nice clean calculation, you did it wrong because you're doing a measurement. You can't get a clean calculation. It's exactly the opposite. But in the math sense, the problems that I did today using Stokes' theorem, Would you say those problems were short and sweet, or would you say they were long and involved?
Pretty short, to be
The
honest.
two, I don't know.
Oh, yeah.
I think they were
I
fairly
mean-
long. Were they difficult? No, but they were long. But in both cases, the answers were really simple. They were nice, happy numbers, and there was nothing complex about the calculation because it wasn't necessary. There's too much involved in the setup. If the calculation is nasty, everyone will think they did it wrong because they're so used to it being clean. I tend to make that problem cleaner because I don't want people getting killed by the numbers. It doesn't mean you can't get an ugly number. Somebody gets a log 2, they go, oh, I must have done it wrong. Log 2, really? That's pretty friendly. Square root of 6. It's like what you said. I got a million things going on, but then I've seen the nature of things going, you know what? I've seen answers like this before. Maybe that's not so bad. And if you don't see anything wrong with it, you have to leave it alone because it's more likely to be right. That's
Or at least that, or don't change it for nothing.
yeah. The absolute rule is always you only change it if you know what you're changing it to. I can't tell you how many times people will erase or cross off an answer and I'll say, why? Well, it just didn't look right, but you didn't replace it. So, what's the penalty for a wrong answer? What's the penalty for the worst, most offensive answer you could ever give? 0. What's the penalty for leaving it blank? 0. So maybe you wrote something correct. That's not 0, but crossing it off, erasing it is 0. So if you don't know what to change it to, just walk away. Now, in this case, because you get to do extra problems, and then it really doesn't make sense to cross off an answer because you don't know if that one's going to end up having to count. And it's a scoreboard. You just want as many points as you can get.
Yeah, I'm never too concerned about my answer on these tests, as long as I'm comfortable that I took the right path to get to the answer. I probably made a mistake, but my logic
Now
is all.
you're going to get 80 to 90% in a likelihood, even with a wrong answer, because you demonstrated correct calculus. And I consider a right answer like frosting on the cake. It means not only was my calculus perfect, but I actually proofread the problem well. And if your only errors are small, it's not going to kill you.
Can the final affect you if you take it?
It can only help you.
It can only help you.
Yeah. Simple, an easy way to think about the final. The final is worth 1 exam and 6 quizzes. The final will replace your worst exam and 6 quizzes if it is better than your worst exam and 6 quizzes.
That's not gonna happen. Okay.
But if you have a lousy exam, you're going, my final better be. If I've got, let's say, 2 good scores and 1 lousy score, well, my final better be better than the lousy score. I got the good scores feeding into it. So if your final exceeds your worst score plus your worst 6 quizzes, which, by the way, most everybody's usually does, then it replaces them and that lifts your grade. If you choose not to take the final, then technically you get a 0 on your final, and now it's lower than those scores, so it's the drop score.
I'm going for the replacing my first test, which was an 81. I'm going to try to get 90s on this next test, and then the final and try to push to an A.
Yeah, and by the way, then if you fall short, you say, well, at least I got a B. But
yeah,
it's what drives me crazy, and it happens every single semester. It's the not trying at all. I had this conversation in my discrete yesterday because most of you are 2-day-a-week people. Most people at Mesa are 2-day-a-week. And technically all finals are supposed to be given on the last day of class. Well, do the math. That means some of you have 4 finals in a row, on the same day. And one of them might be, I know Josue won't like this, but I always refer to as the evil P word when it comes to math. The destroyer of math students, physics. In other words, people have to devote all their time and attention to their physics. Or maybe it's OChem, it's usually physics. So they'll say, I'll take my B in the calculus class because I need to devote all my time and attention to physics. You should never have to make a choice. You should be able to do both. But the way we do it at Mesa, we don't have a finals week. So all your finals are right in a row on the same day. And you say, I can't afford to not give physics everything. So I will accept a grade that's less than I might have been capable of getting. I can accept the B, but you could have gone for the A. But that means I wouldn't have been able to do as much time in physics. Now at a university, these are spread out over the course of a week, so nobody has to make that decision.
That's basically what's happening to me. I mean, I have an A in physics, but it's sacrificing my calculus grade. You know what I mean?
By the way, that's I've been here for a million years and I see that every semester after Calc 1, not in Calc 1, starting at Calc 2, people have to make the choice. And I wish we didn't have to make a choice.
Yeah.
But it's nobody's fault. It's not right or wrong. It's just the nature of the beast. You guys are carrying gnarly loads and it requires time and attention. And sometimes you have to do this juggling. Saying, I got to put my efforts here because I'm getting a C in this class, but I've already nailed a B in the other. So I got to put everything towards my C. This is the norm. It's life. I wish it wasn't that way. I wish everybody could make my class their priority. But I know that's not reality. I wish it was, but it isn't,
I remember last spring, I had that same situation. And especially because I have the DSPS, so my test times are longer. So I woke up at 8 and started taking the math test till 11, and then at 11:10 my physics test started until 3:30.
Oh, yeah, this is why, by the way, every semester, certainly while we were on campus, every semester I have a significant number of students who ask to take their final a day or two early for exactly that reason. Because in every class I teach, I have 2 reviews, not because we're going to review. No, it's actually to put the cushion of time. See, if you have 2 reviews, that means you have that much more time to prepare. Whether you physically use the in-class time or not, it's not relevant. But if you've got 9 days or 12 days to prepare for final with no new material, then you can be far more prepared. Whereas if you're lecturing the day before the final, no, it doesn't work. So I have a lot of students will say, oh my God, I have 4 finals in a row on that Thursday. Mr. Brown, can I take your final on Tuesday or Wednesday? The answer is always yes. And then I'll just try to direct you towards another class that's taking a final. So then you can not only take your final early, but you can take it with another class that has a final. So now you have an uninterrupted, quiet environment, all those good things. And if that doesn't work, I gave a final to one of your classmates I'm sorry, not the final, the exam 3 to one of your classmates really early this morning. We started at 6:30. He needed to take it early. He originally wanted to take it last week. I talked him out of it. His wife is on the verge of popping. In fact, she said she started going into contractions last night. So he wasn't even sure. He's handling it pretty well. He's a little bit stressed. It looks like he hasn't slept in a little while. And basically our last email last night was, okay, we'll start at 6:30. If you're not there, I'll know why. Because it means his wife went into labor in the middle of the night. So
You might want to drop that final.
well, no, this is an excellent student. This is a great, terrific student, but he's in the situation where, oh my God, he wanted to actually take it a week ago. And I talked him out of it because his wife's not technically due till next week, but she was showing signs of being really early. And
yeah, I know, but he may be busy in 2 weeks and may not want to take that final test.
But hopefully he won't. Hopefully the student won't need to take the final. But it's one of these things where even as of last night, and I'm going, no, and he kept thanking me, this is not even an inconvenience. I'm already up. And I just used my morning classes link, and he finished like 2 or 3 minutes before the first student logged on for that class. So there wasn't even a conflict. But because I was able to do that, this guy's now done. He doesn't have to think math for at least a week now, because he doesn't have to do the test on Thursday. And it's very likely his wife will have had the baby sometime in that time. And now he can devote all his time and attention to where it's more important, and I'm glad I could do that. I had a situation several years ago on campus. I had a student, a really good student, and it's late in the semester. I think it might've been this class. And he's like, yeah, my wife is due in, a couple of weeks, blah, 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 blah. And I'm in my office and he walks in, he's just frantic, goes, can I take my test now? My wife's going into labor. I said, why are you here? My wife is going into labor. Can I take my test now? Yes. He worked for 15 minutes. Like, your wife's in labor. You should be rushing her to the hospital. You shouldn't be starting your calculus test.
No, you're not going to get a very good score on that one.
Well, it's not even about that. It's like, buddy, do you realize what you're saying? He's the one who's going to take her to the hospital. He's like, well, she can wait an hour or two. Is kind of, and then it dawned on him a few minutes later that he just said, never mind. And that was his drop score. He had to take the final. Everything worked out okay. But to this day, I told my wife about that, and she's like, if that was my husband, I would have killed him. My wife's going into labor. He doesn't live 30 seconds from campus, mind you. So he's got to go get his wife and then rush her to the hospital. You have no idea how long labor is going to last. It could be minutes, it could be hours. So it was a very funny situation, you know. That happened to us once. We were home. My wife's like, I'm in labor. I'm like, oh, okay, no big deal. Let's take our time. So we took our time. We get to the hospital. We get checked into the room, and 5 minutes later, my son's born. She didn't even have time for the epidural. That's the painkiller. It was so that nobody even was there. Family wanted to come. It was a ridiculously, but she didn't. It was like totally cool, you know, like no big deal. And my wife was so relaxed. Oh yeah, honey, we should probably go. You know, I'm like, okay, I'm cool. Yeah, like I say, we've had labors that lasted all night long, and this one just seemed like it was 5 minutes long, and something you guys get to look forward to, by the way. And then you'll never sleep again.
I'd rather do calculus all night. Thank you.
Then do babies?
Yeah, thanks. I'm good.
No, not yet. No, but hopefully someday. Someday. All right.
Eventually.
Is there anything on this test? Any particular questions on the practice test, on the quiz? Anything that you guys want to go over? Are you good?
I'm more or less good. I know.
I'm not. I don't even know what I'm doing.
I'm gonna take off that.
Well, I would suggest hammer out problems that you've already done, like previous quizzes. Grade yourself and say, am I getting them right? If I got them right the first time, am I still getting them right? And trust yourself.
It's not gonna happen, Professor. I know. I have a feeling that I'm just not gonna make it this semester. Like I don't know. I just have so much work. It's not even that. It's just like I'm just so much is in my mind right now. I just can't even focus.
I have noticed the last couple of weeks you've been far more distracted, and
I've been out.
There's stuff, non-school stuff. I mean, you got 2 more weeks. You just got to survive 2 more.
I just feel like I'm not even. Before I used to like aim for the A, and then things start to go, you know, exponentially worse, and I started aiming for the B, and now I'm just even aiming to even pass your class, and that's kind of that.
I don't think that's.
Down,
I don't think that's really an issue. I don't think passing is the issue. I still think a B is within reach, but you're going to have a good test. But the thing is, I have a student in one of my other classes. He did not do well on the first test, and he's one of these people. He participates in lecture and has the answers and is pretty sharp, but you might appreciate this, never trusts himself. When he's right, he doesn't believe that he's right, and so he sometimes is skeptical. So the second exam comes around, he's Mr. Doom and Destruction. Oh, I'm probably going to fail, and then I'm probably going to drop the class, and he gets like, I don't know, 86, 87%. I think he cried. He was so ecstatic, and he couldn't believe I really do know this stuff. And since then, he's been getting A's on all of the quizzes, and I wouldn't be surprised if he nails this test. He was ready to quit because he'd convinced himself that he just couldn't do it. And when he got right answers, it was like accidental, you know, I don't really know it. And he really did. But I haven't seen somebody that self-defeating in a while, although sometimes listening to you talk, you're heading down that path. No, you can do this. You know this. You've just got to stop convincing yourself otherwise. When you get an answer, walk away. Maybe that's it. Just don't.
That's what I did last quiz. I mean, last exam. That's exactly what I did because I just couldn't. I don't know, man. It's
But you told me right beforehand you had no faith or confidence in yourself.
I didn't.
But see, you predicted your own time of death. Those kind of prophecies, by the way, are usually self-fulfilling. So let's just do the opposite. Say, you know, Mr. Brown, I'm gonna wow you with this one. I'm gonna surprise you, and don't spend the next 48 hours trying to teach yourself something you're not good at. Spend the next 48 hours working on things you're solid to absolutely be certain. Remember, you don't have to get a perfect score. You've got to get a few perfect answers, which everybody in the class is capable of doing. And then hopefully give me some good answers. You say, I'm not sure if I did this one right, but I know some of the stuff I wrote was good. Then great. Then you can walk away from that one. You know, I'm going to ask you
things. Is that I want to do everything right. Like I want to get the full quiz, and that's I don't know if you noticed, but probably you did. First exam, it was all over the place. second
Yeah,
exam,
what?
it was all over the place because I start switching over. I start freaking out and I start switching over every single page.
You do weird arithmetic stuff. You start questioning whether you added. I'm serious. You had arithmetic weirdness that just didn't make any sense. It's like you're looking at it going, I don't trust my calculator. Don't do that to yourself. It's not worth it. If you make a mistake, you make a mistake, but don't let that mistake steamroll and take out the entire problem, or worse, take out the next problem. It is okay not to be perfect on something. All you're doing is saying, I'm going to do Miss Parsons always calls it a brain dump. I'm going to do a brain dump and just show you everything I know. Not worried about what you don't know. I want to see everything you know. And when you're done showing what you know, walk away from that problem so you don't start, messing with it and say, you know what, I don't know anymore on this one.
It's probably just that what you're saying. I mean, like it kind of brings me down a little bit that I was getting, I got an 8, not even, it's like more than 100% on Calc 1, and then Calc 2 came around, which was summer of COVID starting, and it's just from there it's just been going down. Like I know the material. I know I've been to your class. I listened to your lectures more than 50 times before a quiz, and I try to do everything. It's just that when I'm doing it, I'm just like, it just doesn't look right.
Do you have problems focusing?
A little bit, yeah.
I don't know if I've talked with you about this, but I've talked with a few different students about different things. For example, have you heard of St. John's Wort? Have we had this conversation before?
No, we haven't.
I know I had this, then it was with probably the other guy that was talking about. My father used to take this. My son's taken this before. St. John's Wort, it's a natural herb that just people swear by, that it just helps them focus. There's no side effects. There's nothing dangerous. And it's not a prescription. It's something you get at Trader Joe's or Sprouts, but it's one of these things that a lot of people swear by, saying, you know what, this really helps. But believe it or not, there's a lot of natural things. I've looked up everything because I have a lot of kids who will have focus issues. And sometimes it's dietary. The best thing you can possibly eat for the test? Blueberries. Believe it or not, that's one of the best things that are on planet Earth to help you focus, to help your mind not get so distracted. Plus, make sure you're in an environment, lock your door, make sure you're in an environment where you cannot be bothered or disturbed for that 2 hours, and try not to set yourself up. I got an appointment right after class. Clear your schedule so that there is nothing that's going to get in the way, because right now you're a person that can do it, but you're easily distracted. And when you get distracted, that can be the
freak out. Yeah.
Now, by the way, this may be something that you might want to look at in the long run over at like Disabled Student Services and stuff. You might have some issues, because I've had so many students over the years that their disability technically was they're so distracted so easily that the only way they can do tests is in a perfectly quiet environment. So that I will try to create that environment. And that is something that you probably need. Now, what about something as simple as headphones? Do you have headphones?
Probably I should put my noise canceling. Yeah, I have my AirPods that go noise canceling. Like I can't hear anything with these.
I would wear those, and maybe if I need to reach you, I'll chat you. But again, if you are distracted by that outside conversation in the other room, or by the TV being on, if any of that is going to get to you, you've got to eliminate it, because
that's the funny part. I mean, I didn't need that before. I guess it's just, things change, I guess I'm just in denial that I need a quiet space.
Well, it's not just that. Your stress levels right now are so much more than they were for whatever reason. It could be external. It could be that it's all building up inside. But I don't like to see people go through this. You are way better than what you feel like you're becoming, and you have every chance to completely save the semester. And I don't want to put the pressure on one test, but let's face it, if you have a good test, that will overcome a lot of the evils that have felt like it occurred so far. And then really the sky is the limit. But you've got to create a situation where you can have it. And part of right now, you're doing a psych job on yourself that I wish you wouldn't do. You're going to go into the championship fight. You have the skills to beat this guy, but you're convinced he's going to knock you out. Well, guess what's going to happen? He's going to knock you out. You got to knock him out. You got to knock out this test, and you got to convince yourself you can, because I believe you can. And I'm not just saying that, but right now, you need to just completely change that thought process, and more importantly, maybe eliminate the distractions that are getting in the way. And by the way, get outside, go for a walk, go exercise, go
work. That's literally been my whole schedule for the entirety. Either I go work and I come back and I dive myself in a deep hole of physics and then do math, or do math first because I know physics is gonna take a lot. And I know there's I'm getting out of physics with an A. I have a 93%. I'm doing perfectly there, but then it's just I feel so stupid because I can't do the same thing with math. You know what I mean? Because I'm so distracted in what I'm doing over there, and then I'm doing over here, and then at
Well,
work. I don't know.
I think if you gave math the
I'm
same
just crazy.
attention you gave physics, you probably would be that successful. But there aren't enough hours, and that's where you have to.
Yeah, I know.
And what about this? What about cut back at work for a week or two?
Yeah, that's
Just to
what I
get
want
through
to
this.
do.
Can you do that? Can you cut your hours a little bit for just 2 weeks?
I'm probably gonna tell the. I'm just probably gonna work on Monday and Saturday and Sunday, and probably cut off on Wednesday and Monday and Tuesday
Because it would make
and
sense.
Wednesday.
You take a hit financially, but only for a couple of weeks, so
Yeah.
that you can put in more time.
I
Because
mean, I live with my parents now. I used to live alone. Now I don't, so I guess I don't really need the money, right?
well, I mean, we all need the money, but
Yeah.
you don't want it to be, well, my job or my grade. Oh, I think that's an easy choice, but at the time, it doesn't always seem easy. Anyway, I'm going to let you be,
Right.
Jose. Jose, you email me if you got a question, like always. I'm not going anywhere. All right.
Okay. All right. Thank you very
See
much.
you on Thursday.
Yes, sir.
Let me do this. And